topic, threading. What is a thread? Tell me. Thread is a threads are sub-processes. Very good. Any other definition to thread? Small part of a program. Very good. Correct. Any other definition of a program? Sorry, thread. Yeah. Okay. I will define it. What is a program first of all? Set of instructions. To run that program, there are some steps. What are the steps? Loading that contents of the file to memory, allocating memory first of all, loading that contents into memory, creating a lot of data structures, updating process tables. These are the steps for running the program. These steps for running the program is called as process. After all these steps are done, the instructions inside your program has to be executed. What the operating system will do is it will start a sub process called as thread. The purpose of thread is to execute the instructions inside your program. So whenever you are running a program, at least one thread will be there to execute the instructions, right? So in a program, at least one thread can be there, but in one program, one process, there can be multiple threads possible, right? Who is starting the threads? Tell me. OS, operating system, will be starting a thread. Now suppose if you want to start your own thread, there is a lot of procedure, because you have to ask the operating system to start a thread, then only operating system will start a thread. But if you have to talk to operating system, there is a set of procedure. There are some set of rules which you have to follow when you want to ask the operating system, right? So you have to write a lot of code for asking the operating system to start a thread, right? So if you want to start a thread, there are some steps to be done. In Java, what they gave us is, they gave us a class called thread, and inside thread class there is a method called start, and inside the start there is some code which will ask the operating system to start the thread. So in our Java program, it is very simple. What we have to do is, we have to create an object of thread and then call start, and then call start method. Then the operating system will start a thread. After thread starts, we have to tell what it has to execute. The purpose of thread is what? Execute some code. So after a thread starts, we have to tell this is the code you have to execute, or this is the code you have to run, right? So first we have to define the code which a thread has to run, then we have to start a thread. So these are the steps for starting a thread. Let me explain it to you very clearly. Now first of all, before going ahead with programming, let us try to understand what is the requirement for starting multiple threads. What is the need for multi-threading? Multitasking. Okay, I think we discussed on the first day. What is multi-programming? What is multi-threading? What is multi-processing? What is multi-programming? Tell me. Multiple programs running on the same OS is called as multi-programming. So on my system there are multiple programs running. So our operating system is doing multi-programming. What is multitasking then? Somebody has used a word called multitasking. What is the task then? That is multi-threading. What is multitasking? Task is same as a process. Multitasking and multiprocessing both are same. What is multiprocessing? Yes, multiple programs running in multiple processes is called as multiprocessing. What is multi-threading then? Multiple threads running inside a single process is called as multi-threading. So we understood why is multi-threading required on the first day itself. Because which is better, multi-threading is better or multi-programming is better? Threading. Why? Yes. If an OS have to create a process, there are a lot of steps involved, like allocating memory, creating a lot of data structures, entering inside a process table, and even a lot of other things which we cannot even list also. There are a lot of things which an operating system will do for creating a process. But for creating a thread, it is very simple. Operating system has to allocate only a stack. Creation of thread is very simple. Only a stack is required for a thread. For every thread there will be one stack given by the operating system. So to create a single thread, only stack is required. Tell me, for a thread, operating system requires to allocate memory also or not? Okay, stack is a one type of memory which is required, but is it required to allocate heap memory also for the thread? No, because when creating a process, it has allocated some memory. The same memory will be shared by all the threads running inside the same process. All the threads inside a single process will be sharing same memory. Okay. So when creating a thread, operating system need not allocate memory. Already memory is allocated to a process. So only one thing which is required to be done for creating a thread is to allocate memory for a stack. So once a stack is created, thread can be created by the operating system. So creating a thread is easier than creating a process. That's why we call a thread as lightweight process. Thread is a sub-process, is part of a process, and it is lightweight because creation of thread is very easy. The number of steps the operating system has to do for creating a thread is lesser than the number of steps it has to do for creating a process. So creation of thread is easy. And also another concept which we need to understand is process switch. When multi-programming is happening, operating system will be using some scheduling algorithms to schedule processes, like round robin. If you take, operating system will use round robin to schedule your processes. So each process will be allocated some time slot. After the time slot is over, operating system has to execute another process. But before switching from one process to other, a lot of information has to be saved by the OS. All the information about the currently executing process have to be saved, so that when it resumes that process again, all that information which is available right now will be reloaded. So to switch from one process to other, the operating system has to store a lot of information, but to switch from one thread to other, the information about that thread is already present inside the thread stack, right? To switch from one thread to other, it is very easier. It need not save much information. It is very easy. So switching from one thread to another thread is easier than process switch. So that is another reason why we prefer threading. Okay, not only memory constraint, switching of processes is easier than switching of threads is easier than process switching. So that's why we can prefer multiple threads. Okay, tell me, is there any limit for number of threads inside a single process? No. As long as memory is available for allocating a new stack, a thread can be created. There is no limit, only the constant is memory. As long as memory is available, thread can be created. Okay, we understood about multiple threading. Tell me exactly why multiple threads are required. Why can't we do everything with a single thread? Saves a lot of CPU time. Very good. See, let's assume that in one process, one thread only is there. Let's assume that for one process, some 10 milliseconds of time is allocated by the operating system. If you assume round robin, round robin algorithm, scheduling algorithm, what will the operating system do? It will allocate 10 milliseconds for each process, let's assume. Now, millisecond, okay, it's very less for us, but it is more for a CPU. CPU is very fast. Okay, 10 milliseconds is allocated for a process, and after 1 millisecond, let's assume your process has issued a read command or a print command to a printer. Printer is very slow, IO devices are very slow, so it will take some time for responding IO device. So until the IO device responds, my process will be waiting. So if you assume that there is only one single thread, that thread is waiting for 9 milliseconds. After 1 millisecond, it issued a print command. 9 milliseconds it is waiting. So my CPU time of 9 milliseconds is wasted, right? But if there are multiple threads, what can happen? When one thread is waiting for a printer, another thread can take over the CPU and execute it, right? So this is an example of when multi-threading is required. So we have discussed about advantages of threads. Multi-threading, by using multi-threading we can develop asynchronous program, and also we can increase the performance. Now, how to start a thread? How can my program start a thread? First step, my program should request the operating system to start a thread, because the operating system is the one which is managing all the processes and also threads. So you cannot start a thread, your program cannot directly start a thread, you have to request the operating system to start a thread. But there are different operating systems in the world: Linux, OS, Mac, Windows, right? So for each operating system there will be a different procedure to ask to start a thread. So I cannot master all the operating systems, so there should be some easy way for me. What Java has done is they have written a class called thread, and inside thread class there is a method called start. They have already written a code inside start. The code inside start, what we do is ask the operating system to start a thread. Once the thread starts, we have to tell what is the code to be executed by the thread, right? What is the code to be run by the thread. First, before we start a thread, before we write a program to start a thread, we should decide what my thread should do. Okay? What my thread should run, what code should my thread run. So first step in writing our own threads is we have to write some runnable code, a code which can be run by a thread, right? So tell me, if well, we're talking about exceptions we discussed. If an object has to be thrown, if I have to throw some object, what we should do? If I'm writing my own class X, I want this X to be thrown. Will I be able to throw any objects? No. Any class which extends throwable can only be thrown, right? Now I want to write some class which will contain runnable code. So what I should do is, I should write a class which is implementing runnable, right? So first step in writing your thread is, first write a code which can be runnable. So that code you have to keep in a class which is implementing an interface called runnable. First step is you have to create a class implementing runnable interface. Okay, now I'll start writing. You just see for some time. I will write the code and then I'll explain you. Again, I'll give it time to execute. I'm creating a project called threads. Okay, I am going to create a class which is implementing runnable interface. But what my thread has to do, I am going to start some threads. What my thread has to do is, it has to print its own in 10 text. Simple thread. Later we will go to complicated threads. Simply what it has to do is, every thread will be allocated a name by default. Once my thread starts, it has to print its own name 100 times. That is the thing which I will do. So what I can do is, I can say print name runnable. I am writing a class called print name runnable. Implements runnable interface. So any class which implements this runnable interface will contain some code which can be runnable by a thread. So I am adding unimplemented methods. In this runnable interface there is one method called runnable. I am adding unimplemented methods. The method is run. We have to write a method called run. Inside this run method we have to write whatever the thread has to run. So here I am just saying for, I am writing a for loop for int I is equals to 0, I less than 100, I plus plus system.out.println something. I am just pressing A plus I. Yep. See, if this code is executed, what it will print? It will print A1, A2, A3 up to A100, A0 to A99, right? So this is the code which I want to execute once my thread starts. This is the code which I want my thread to run. That's why I kept it in a class which is implementing runnable. Now I am going to write a class called thread starter which will start. Okay, I will keep it in a package. First I will create a package com.accenture and I will drag and drop this class inside the package. Yeah, now automatically package came. See, once I dragged and dropped. Okay, now I am going to create a new class, thread starter. I will take main method. Here I will just write system.out.println before starting thread. Then here what I will do is I will create an object of print name runnable. Print name runnable. Runnable is equals to new print name runnable. I create an object of runnable class. Tell me, is it a thread class? No, this is not a thread class. It is a class which is containing runnable code. This is not a thread. This is a class which is having runnable code, right? Now see what I will do. I am going to create an object of thread class. There is a class called thread, new thread from java.lang. See, this thread is having a lot of constructors. There is one constructor which is taking runnable as parameter, right? Can I pass this object? Because this is taking runnable as parameter, I can pass runnable object here. So I will pass runnable, sorry, the smaller. Thread t is equals to then t dot start. Okay, let me explain you clearly what will happen in this case. I will start with debugging. See, I want the control to stop once it comes to this line. So what I am doing is I am keeping a breakpoint here. Double click on the blue line, it will keep a breakpoint. It will create a breakpoint. You can type it afterward, just try to understand the concept first. Okay, here also I want to create a breakpoint. I create a breakpoint. I will start debugging this. Debug as Java application. So it is asking to switch to debug perspective, click on yes. Yeah, now you can see how many threads are there. There is a thread whose name is main. You can see whatever is in this bracket is called the name of the thread. The name of this thread is main, because who is executing the main method? Main thread. See, you are inside main method, the control is inside main method, who is executing it? Main thread. So only one thread is there, and that thread, as I kept a breakpoint at line number 9, it is suspended here, right? And here you are seeing the top of the stack. Now F6 I will press. See, there is an object of runnable created. Once this is executed, runnable object got created, but this is not a thread, remember. It is just an object in which I have written the code which has to be run by the thread. Then here I am creating a new thread. This will create a thread object. Okay, F6. This will create a thread object only. A new thread is not started again. As I told, thread class is having a method called start. Inside the start method, there is some code which will ask the operating system to start a thread. Okay. So a new thread will start. Oh, wait. Before doing this, I'll just write a system.out.println after this. After starting thread in main. Okay, now I'll debug again. See the flow again. You'll understand very clearly. Now the control is here, F6. It created an object of print name runnable. You have to see here in the variables tab, it created an object of print name runnable. F6 again, it creates an object of thread class. And if I call start, what it will do? It will ask the operating system to start a thread. Right? What is the duty of the thread? To execute some code, right? So once it starts, what is the code it has to execute? We have already passed, when creating thread object, we have already passed the reference of this runnable object. So once the thread starts, what it will do? It will start executing the run method of this runnable objects. Okay? So now I have already kept a breakpoint here. Once the control comes, it will stop. I have already kept a breakpoint. Okay, coming here, I'll press F6. See? Do you see another thread is started? This is the main thread. At line number 13 it is suspended. But here another thread 0 is started. At line number 8, here it is suspended. So calling thread.start has started thread. Ask the operating system to start a thread. Operating system has started thread. And once the thread starts, how will it understand which method to run? See? Once the thread starts, it's calling thread.run. It is calling print name runnable dot run. So in a runnable class, what are we defining? We are defining the code which has to be run by the, then we are creating a thread separately. Now if I press F8, everything, F6 means go to next line and stop. F8 means continue until it finds next breakpoint or till the end of the program. Now what I will do is, I will double click here. The breakpoint is gone now. If I press F8, again see, it came here because in the main thread I kept a breakpoint. Again it break here. Again if I press F8, it terminated. See the outputs? From here the output of main thread, here the output of the other threads, right? Any doubts? I'll explain you clearly again. So first, if you want to start writing your own thread, you have to define once the thread starts what it has to run. To write such code which will be run by a thread, you have to write in a class which is implementing runnable. So first I decided this is the code, I want to print this 100 times. I decided, and I wrote a class implementing runnable interface. I wrote all the code here inside the run method. Okay. So now I have defined what the thread has to run. Once I have done this, I have to create a thread object and pass the reference of this runnable. Then I should call t.start. This will start a thread, and that thread will start running parallelly. Main thread also will start running parallelly. Okay. Now, say this. Will this code be executed by some thread? This code is executed by some thread or not? Is it executed by main thread or not? In this case, is this code executed by main thread? No. A new thread which is started is executing this code, right? What is the name of the thread if you saw? Okay, see here. What is the name of this thread? I'll press F8. Oh, okay, I'll again start. F6. F6. Okay, let me keep a breakpoint. Yeah, what is the name of this thread? Tell me. Thread 0. By default, JVM allocated some name to it. Thread 0. We can also allocate a name to thread. Well, I'll show you. But by default, JVM has allocated a name called thread 0. If I start again another thread, thread 1, thread 2, thread 3. So every thread will be having its own name, right? Okay, now once you understand this, this code is executed by some thread which will be having some name, right? Can you tell which thread will be executing this? Thread 0 or thread 1 or thread 2? Some thread will be executing it. Can you say? But we don't say exactly which thread, right? So some thread will be executing it, right? So if you want to get the reference of the thread object which is executing this code, then you have to do like this. Thread dot current thread. Inside thread class there is a static method called current thread which will give the reference of the thread object which is executing it. So current thread is equals to now here I just wanted to print thread name. Current thread dot get name is used to print the name of the thread. Okay. So what I told, I want to write a program which will print its own name. Okay. Now if I run the program, let us see what it will print. See, it has printed thread 0, its own name 100 times, right? So here in this program, if I run this program, how many threads are started? Tell me. 1, 2, 3, 4. 1 or 2? Main thread is also there. Main thread is 1 and your one thread is 1. Right. Now I want to create 10 such threads. I have already defined what code a thread has to execute. Now I want the same code to be executed by 10 threads parallel. See what I will do. Can I do like this? Tell me. New thread of runnable dot start. Is it not equivalent to calling t dot start? I am taking this reference in t and calling t dot start earlier. In the 2 steps, I combine 2 steps into one line. New thread of runnable. On that object, I am calling start. Okay. So this will start how many threads? 1 thread. Now I created 1, 2, 3, 4, 5, 6 threads I started. All the threads once they start, what they will be executing? Same code, right? But each thread will be assigned a unique name, thread 0, thread 1, thread 2. Let us see the output. Yeah, if you see the output is interleaved, is it? See, first main thread started, then thread 0 started executing. Again, thread 1 got a chance. Thread 1 again got a chance. Again 0. Again 0. And here thread 5 got a chance. It printed 3 times. Then again thread 1 got a chance. Thread 5, thread 0, thread 4, thread 2. See, Are you able to predict the output? No. Once a thread starts, it is its own. There is no parent and child relationship. Who is the parent for all these threads? Main thread, right? There is no parent and child relationship. Each of them can run individually, right? So that's how I started 5 threads or 6 threads right now. All the threads executing the same code. I'll show you by debugging. I kept a breakpoint here and I'll show you by debugging. Yeah, see here. Okay, I will press F8. See now, see this stack trace here. How many threads are there? Thread 0, thread Z, thread 3, thread 1, thread 5, thread 4, thread 2. All the threads are started and they are executing. All of them were suspended because I kept a breakpoint at that line. All threads. You can see all the threads started and they will be running parallelly. But once the thread starts, everything is on its own. They will be running parallelly. How will they run parallelly? Okay, see here, once my program starts, main thread starts running. Main thread has created 6 more threads. Let's assume that operating system is using some algorithm like round robin, a very simple algorithm, round robin scheduling algorithm. If it has taken round robin scheduling algorithm, first main thread was executing. After some time slot, main thread time slot is over. The other threads are also ready. It will give a chance to execute for the threads. Let's assume thread 1 gets a chance. After that thread 1 is executed, again its time slot also is over after some time, then next thread. Like that, accordingly, all the threads will be executed in their own time slot. But as the CPU is very fast, we will get a feeling that they are running parallelly. Actually, threads, are they running parallelly? Now CPU can run one instruction at a time. There is nothing called parallel execution. CPU can run only one step at a time. But as the CPU is very fast, we will feel that as if the threads are running parallel. Okay, any doubts? I want to give my own name to the thread. By default it was giving thread 0, thread 1, thread 2, right? If I want to give my own name to a thread, see, there are a lot of constructors of thread. See the constructor. See, there is a constructor which is taking runnable comma name. If I use this constructor, I will be able to give my own name to the thread. By default, if I don't give any name, it will be thread 0, thread 1 like that. So I will use this constructor. First parameter is what? Runnable. Comma the name. Tell me one of the name. One of your names. Huh? Vinay. Okay, Vinay. Tell me another name. I want 6 names. I will make all your threads. Huh? Any other name? Where is that attendance sheet? Annaya? Neha? Varun is over. Jin? I give my own names now. If I run this, it will print these as the names. So Jingur is at the last. So tell me, I created Ramesh at the last, but Ramesh, will it end at the last? No, why? Always Jingur is ending at the last. And now Chichi. So the order of execution of the threads is not in our hands. Okay, what I mean to say is, order of execution of the threads is not in our hands. Once the thread starts, every thread is its own. Okay, every thread will have its life cycle. So first, now if you understand the life cycle of thread, then you'll understand why you are getting output very clearly. Let us try to understand the life cycle of a thread. Okay, so when a thread is created, means when I created a new thread, but I didn't call start method. So it is set to be in state called new. When I created an object of thread but didn't start it, it is in new state. Once I called start method on the thread object, it went to runnable state, means it is ready to run. But CPU will not immediately run it. It will go to ready to run. Runnable means ready to run. It can be runnable. Okay. So whenever I call start on thread object, threads are not starting immediately. They are going to runnable state, means they are ready to run. Then who will decide which thread to run? Inside our JVM there will be again a scheduler. Thread scheduler will decide according to its own algorithm. It will decide which thread to run. It will pick some random thread according to its own algorithm. So whenever I call start method, thread is not running immediately. It does not start immediately. It is ready to run. It is in runnable state. Okay. Then after some time, thread scheduler will decide to execute that particular thread. Then when the thread is executing, we say that it is in running state. Okay. Then let's assume our scheduler is following round robin algorithm. Time slot allocated for the thread will be over after some time. After time slot allocated for the thread is over, then the thread will come from running to again runnable state. Now again it is ready to run. When time slot is over, again it will come from running to runnable state. Then CPU, the scheduler will choose another thread which is ready, right? Suppose when the thread is still running, it gave an IO operation. Suppose it gave a print to printer, print command to printer. Printer will be very light. So this thread has to wait until the printer responds, right? But let's assume that scheduler has allocated some 5 milliseconds to this thread. In the second millisecond, it has issued a command to printer. Printer is very late. Will it be good if this 3 milliseconds, if the thread is waiting for 3 milliseconds? Will it not be good if the CPU is released for the 3 seconds also? Right? When the thread is waiting for something, it will go to blocked state or wait state or sleep state. There are 3 names. Blocked state or wait state or sleep state, all are same. When thread is waiting for a particular IO device, it will be in wait state. But after some time, let's assume why the thread which was running came to this state? Because it was waiting for a printer, right? Waiting for a printer means what? The operating system might have generated an interrupt for the printer. Even electronic students know about this interrupt, right? Yes. So when my thread asked to print gave a command for printer, my OS will give a interrupt for that printer, right? The printer will again respond. Until the printer responds, it will be in blocked state. Once the printer responds, now again thread will come to runnable state. It is ready to run now. When it is in blocked state, it is not ready to run. When it comes again, when the printer responds, it will come to runnable state. Okay. Then like that, this cycle will go on, right? And after the code inside run method is complete, then it will go from running state to dead state or exit state, we call it. Okay. So this is the life cycle of a thread. These are the various states of life cycle in a thread. I say that this is not a best way to create a thread, because whenever I want to create a start, what I am doing, I am creating a thread operation calling start, right? So I feel that this is not a good way. If I just create an object of runnable, a thread should be automatically started for me. So I will just comment all this. What I want to do is, if I want to start some 6 threads, so this should start how many? 6 threads. Just by creating an object of runnable class, I want a thread to be started. How is it possible? Let us see now. I am going to modify, I am going to write a constructor for print name runnable. Whenever an object is created, immediately constructor is called. So I wrote a constructor for this. And here I will take name, string name. And then I will create a new thread object dot start. Will it be okay? New thread dot start. Am I passing the runnable object? Once, so I am not passing runnable object. Once the thread starts, which code it has to run, it does not know, right? So now what I'll pass is this. This means the current object, right? This is runnable object only. This class is implementing runnable. So there is a thread constructor which takes runnable. So this means runnable. So once the constructor is called, what I am doing? I am creating a thread and passing this reference and calling start, comma. I want the name also. Whatever I am passing through the constructor, I am passing the same here, right? Will this be not a good idea? So this is the way we follow and we create threads. See here what I did is, I created new thread object. I passed runnable object and name. Then I call start. This step I don't want to write separately whenever I want to start a thread. If I just create an object of print name runnable, I want thread to start. So immediately after object is created, constructor will be executed. Now I am going to copy this first line into constructor of print name runnable. Okay, what is this? This is the name, right? Name of the thread. So I'll pass name, because whatever I pass to this constructor will pass here. And what is this? It is a runnable object. Runnable means current. I can pass this, right? So instead of writing it there, same code I wrote inside a constructor. So if I create an object of print name runnable, it will be started, right? So this is the way which we do. Business intelligence, there are a lot of business intelligence. In SAP also there is business intelligence. No, in database, Oracle, Python, also you can do business intelligence. Business intelligence is nothing but data mining. Developing applications. Should be like features for guests. Okay, I'll tell you later. Okay. You concentrate here. Don't worry, that's what I said. But you may get a best project. See, you may get a best project. Why we are getting more business and why we are you are just a research student. Mostly they'll give preference to put in Java project, but you may not always put in Java. You are just made aware of various technologies. Okay. So what 90% will be in Java projects. 10%. Cloud computing is not separate from Java. Cloud computing is using Java. Cloud computing can be done using .NET also. But cloud computing is there with Java also. That's why I said cloud computing is Java. Business intelligence is related to SAP or database. Okay, that's also very good. That is not related to Java. In Java, you have a lot of things. That whatever the cloud computing is there in Java also. Don't be worried. You are very lucky you are in Java. And Java has very good scope. Don't worry.
And how about BI then?
BI is also very good.
I'm not asking because I already have this plan in mind to go for MBA after 3 to 4 years. But now I'm getting BI at one side and my career will take a turn from this.
You are going for MBA? You are planning to go for MBA?
Yeah.
Then go for BA. Business intelligence. So BA is nothing but just a little. BA is nothing but future forecasting. Based on the past data, you will be creating forecasting about the next future based on the past data. So for that there are various tools. You will be learning some one of the tool, BA tool. SAP has one of its BA tools. And like that there are a lot of other tools. When you are in BA, you will be learning a tool. Okay? That's it. Okay, just concentrate here. We have no time. We have to complete a lot of topics today. So what we understood is, in the constructor of runnable class only we will create a thread. So now if this is the case, what I can do is, if I just create an object of print name runnable, it will start a thread. This is the best approach for creating a thread. If somebody asks you to create a thread, what to do is, you create a class implementing runnable, and implement in the run method you write whatever you want the thread to execute. Then inside the constructor, write like this. These are very best approach to start a thread. Okay, now why is it giving error here? Print name runnable constructor is taking string name. So I have to pass all this here. Okay, sufficient. So this will start 4 threads and print. Okay. Now here all the threads are printing immediately, right? Once the thread starts executing this line, I want the thread to go to sleep state. Means the thread should release its CPU. So what I can do is, if I want the thread to go to sleep state, I can call thread dot sleep. There is a method, static method called sleep inside thread. If you call thread dot sleep, the thread which is executing this line will sleep for some time. Here we are tells time in milliseconds. I want it to sleep for 1 second, I give 1000. So thread dot sleep means if any thread is executing it, it will sleep for 1 second, then 1000 milliseconds. This thread dot sleep is throwing an exception. I'll catch it. Tell me, can I make my run method to throw? Why? We have understood while overriding, the overridden method should not throw any extra exceptions, right? The run method of runnable interface is not throwing any exceptions. So in the implementation class, you should not throw any exceptions. It will give a compilation error. So I need to catch it. Surround with try catch. Yeah. Now if I run, you can see the output very clearly. See, it is printing all the names slowly. Every thread is sleeping for 1 second, 1000 milliseconds. Huh? Now it is looking nice. But sleeping, making a thread to sleep will reduce the performance. It is very slow. Okay, I'll terminate. Here I clicked on red button, I terminated. Next, once you understand this, there is another way to create a thread. We saw one way to create a thread is first write a class implementing runnable and then create a thread by using this statement, right? There is another way to create a thread. Let us see. First you listen it and I'll explain you clearly. I'll give it time to execute it. Now I'm creating a new class, print name thread. See here, this is a class and I'm extending thread. Extends thread. And I will override a method called run. What did you understand? Here is thread class is already implementing runnable. If you see the API, thread is present in which package? Java.lang package. Thread class is having, if you see the thread class, it is implementing runnable. So inside thread class itself there is runnable method. What you can do, you can override it, right? So the other way of creating a thread is you can extend thread and override the run method, and you can write the similar logic here. For int I is equals to 0, I less than 100, I plus plus. Tell me, to print a thread name, what is the method you need to call on thread object? Thread dot get name. Thread dot get name. This is a thread class itself. Directly you can call get name. So I will write system dot out dot println get name, because it is extending thread class. Get name is present inside it, right? The current thread, this dot get name. Same thread object will be executing this run method. So this is another way. Then what I can do is I can create a constructor print name threads which will take a string name, then can I call start? Start method is present in thread class, which is inherited, right? Thread class is having start method. So I am directly calling start method. Okay. This is another way to create a thread. And what about the name? How do I assign a name? There are two ways. What I can do is I can call set name and assign the name. This will assign the name to the thread. This is one way. Then I am starting it. Or see, thread class is having a lot of constructors. Thread class is having a lot of constructors. There is one constructor which is taking name. So when from subclass constructor, if I want to call superclass constructor, what I will do? Super and pass the name. It will invoke a thread constructor which is taking name. This is the normal way which we do. Okay. So in my demo class thread starter, if I have to start a thread by using that class, what I can do now? New print name thread and I'll pass the name. So this will start two threads. Once I run this program, my main thread will start, and creating, when this is executed, the constructor is called. In the constructor, what I am doing? I am calling start method. Start method is inherited from where? Thread class. This will ask the thread to start, and after the thread is started, which it will execute? Run method. Right? See this and let me know if you have any doubts.